Welcome to Fast Math Solutions on Maths with EJD. In this video, we will evaluate the integral ln x dx. Now, when you see this kind of integral, first of all, you may be wondering what exactly you need to do. Well, the answer may not be as obvious as it looks. Though you know what integral is about and you know what ln x is. But especially if you try to integrate ln x, you discover that it's difficult to actually integrate directly, right? But the only thing you know is that if you differentiate ln x, you get 1 over x. So, but then we have to, it is integration we are here to do. So that can be quite a challenge. But then let's see how we can treat this. The approach to this would be to use integration by parts. And this is how we obtain the derivation of integration by parts. Now, if you know under differentiation, of course, I'll be making videos on calculus very soon, and I'll be dealing with all of these things. So if you have y equals uv, u multiplied by v is actually a product. So, and that leads us to product rule, right? Which is dy dx equals u dv dx plus v du dx, and since dx is common to all the sides, they can multiply through by dx. And if you do that, it ends up giving you dy equals u dv plus v du. And then if you take the integral of both sides, so you have integral of dy, equals integral of u dv equals integral of v du. And of course, again, integral of d anything is that thing, right? Integral of du is actually u plus a constant c, right? So integral of dy is y. Then, of course, you have integral of u dv plus integral of v du. So, and remember that y is actually v, so you can bring this over here. Since y is v, so you can put the value of y, which is uv rather. Y is uv. So it means you have uv equals integral of u dv plus integral of v du. So from here now, you can make integral of u dv the subject of formula. So that's integral of u dv equals uv minus integral of v du. That means you moved this here, and then you have integral of u dv equals this uv minus integral of v du. Now, why did I have to do all this? To evaluate the integral ln x, we are going to use integration by parts, right? So, and this is how it goes. To explain this expression, right? You have, so it means whatever, if anyway you have to use this formula, right? From the expression itself, you should be able to isolate a part which is u, and you should isolate another part which is dv. And then once you isolate the part which is u and the part which is dv, then from there you can get uv and integral of v du. How do you get, of course, you already know u, so you can easily put it here. Then you have dv, so you need to integrate dv to get v. Then here you need v, which you already, okay, the v you have here, you can use it here. Then this is du. So how do you get du from u? You differentiate u and you get du. And like you already know, it's easy to differentiate ln x than to integrate it. So the trick we are then going to use is to say that since I equals integral of ln x dx, it's the same thing as integral of 1 times ln x dx, because 1 times ln x is still ln x. And since you know it is easy to differentiate ln x, then you can take ln x as your u, because u is that thing which you need to differentiate to get du. And then what will be your dv? Your dv will automatically be whatever is left. That is 1 times dx. So your dv is 1 times dx, which is actually dx. So by doing this, the problem becomes easier to handle. So you have u to be ln x, and since for you have to differentiate, and you can easily differentiate ln x, then the rest, 1 times dx, you have dv equals dx. So now, so since you need du here, so u is ln x, so du dx is simply 1 over x. If when you differentiate a logarithmic function, right, you get so that the result you get is the derivative of x, which is 1, all over the original thing, which is x. So du dx is 1 over x. So since it's 1 over x, you can make du the subject by multiplying through by dx. So you have du equals 1 over x dx. And then for the dv side, you have dv equals dx. So you integrate both sides. So you have integral of dv and integral of dx. Integral of dv gives v, integral of dx gives x. And then plus you have to add an arbitrary constant. Okay. Now that all of those are in place, you have your u, which you need. You have your du, which you also need. You also have your v, which you need. So u, you have it. V, you have it. Then du, you also have that. So all you just need to do is to put everything together. So integral of u dv now is equal to, so you can call that I, which you need to evaluate. I equals integral of u dv, which is our u. Okay, and this is equal to uv. So u is ln x, v is x. This is a constant, so we can let it rest and bring it later when we are done with everything. And that minus integral of v, and that v is x again, times du, and du is 1 over x dx. So now we have put all the pieces together. So you have integral, okay, let me leave this so it can be clear. Integral of u dv equals uv minus integral of v du, like that. So you can then go ahead and tidy things up. So ln x times x is actually x ln x. Don't make the mistake of saying it is ln x squared. No, because ln x is covering x like this. So the x has to come back. So you have x ln x minus, this cancels out. So you have integral of dx left. So you have x ln x minus integral of dx. So this is x ln x minus, when you integrate dx, you get x. Then you can now add the constant of arbitrary constant c. So how do you know that this is correct? Can you try to differentiate this? If you have d dx of x ln x minus x, it's very hard when I'm recording and I need to write it. The writing doesn't come out well. That's why I prefer to write before recording. So if you want to differentiate x ln x minus x, right? So x ln x is product rule, right? So keep x, differentiate ln x, you get 1 over x. Then keep ln x and you differentiate x, you get ln x minus differentiate x, you get 1. So x cancels x. So you have 1 plus ln x minus 1. So minus 1 cancels plus 1, and you have ln x left. So you see, you get the ln x back. So that means that this is the integral of that expression, because when you integrate something, the result you get by integrating something, but if you differentiate that result, you should get the original function back. And so this shows that what we have done is cool. So that's the end of this video. Be sure to subscribe to this channel and hit the notification bell so you can always get video alerts. Thank you. See you in the next video.